All right, so now what we're going to do is we're going to look at that first example, back to the tapping on cans. So if you haven't already, pause the video and enter in this data right here into your calculator. Make sure it is in list, the seconds are in list 1, and the amount of soda remaining is in list 2. Okay, so talking about residuals. So remember, the residual is the difference between an observed value of the response variable and the value that's predicted by the regression line. So observed minus predicted, so y minus y hat. We've also been talking about it or thinking of it as our actual minus our predicted. All right. So down here, it's saying find and interpret the residual for the can that was tapped for 4 seconds and had 260 milliliters of soda remaining. Show all your work and interpret in complete sentences. So check out the calculator video I'm going to post with this to see how to find your residuals on the calculator. But this is how we would do it by hand. So we have y hat equals 2.635 times, or actually, hold on. My bad. We want to put our y first. So 248.6 plus 2.635 times 4 for the 4 seconds. All right. So then we're going to have y hat equals 259.18 milliliters. All right. So this is our predicted amount. So now what we want to do is we want to find our residual. So again, to find our residual, we're going to take our actual minus our predicted. All right. So that's going to be, if we look at the chart, it's 260, or they tell us right there. So our actual is 260. We subtract our predicted, which is 259.18, and we get our residual of 0.82 milliliters. Okay, so how we would describe that is we'd say this can had 0.82 milliliters more than expected based upon how long it was tapped. Okay, so now we're going to kind of think of it by working backwards. What was the actual amount of soda remaining if a can was tapped for 8 seconds and the residual was negative 2.64? So first we have to figure out what the predicted amount was. So we do that with y hat equals 248.64 plus 2.635 times 8, because we're looking at 8 seconds, and we get y hat equals 269.72. All right, so remember our residual is our actual minus our predicted. And so in this case, we're looking for the actual amount. All right, so we know that our residual, because it tells us, is negative 2.64. and we know that we don't know our actual, but we do know our predicted is 269.72. All right. So all you have to do is solve for y. So we add 269.72 on both sides. And then you get y equals, or our actual amount is 267.08 milliliters. All right. So therefore, the actual amount of soda remaining was 267.08 milliliters. All right. Okay, so next we're going to be talking about the regression line. The least squares regression line of y on x is the line that makes the sum of the squared residuals as small as possible. So we already know that our least squared regression line is 248.6 plus 2.63x. All right. So in regards to storing it, we can do this. We'll do this together in class. Okay, on Monday or Tuesday. But if we're going to make a list of residuals, I'm also going to be showing this to you in a calculator video that I'm going to be posting with this. But essentially for that video, what I would suggest for you to do is make sure the explanatory is in L1. Remember, that was the tapping time in seconds, right? List 2 is going to be your soda remaining. And what we're going to do on our calculator is we're going to find both the residuals and the predicted. The residuals will just be one button click. And then the predicted, we're going to be taking two lists and subtracting them. All right. So next, we're going to be looking at a residual plot. So a residual plot is a scatter plot of the residuals against the explanatory variable. Residual plots help assess whether a linear model is appropriate. So we have our graph for our L1, which is our tapping time, versus L4. Actually, here's a slight typo. It should be L3. Our third list is going to be our residuals. All right, but notice how we have our two residual plots, our residual plot here, and our scatter plot. And so remember how we were talking before, a good residual plot has its data kind of like scattered around, right? This was our good one. And then a bad residual plot kind of makes like some sort of U shape. All right. Good, bad. All right. So looking at this one, what is it? Is it making a U shape, or does it have data scattered on both sides of it? In this case, you guys, this linear model is appropriate. All right. So the linear model, notice how I'm using the word that they gave me. The linear model is appropriate for the data, to model the data. Because there is no leftover pattern. In the residual plot. Oops. All right. So we did example 2 in class. With period 6, we actually had time to do the residuals and the prediction on our calculators. So when I post this key up, this is how you find the residuals, and this one is how you find the predicted if you needed to write down the steps.